take charge of the camera because we're going to burn through this board in like 2 minutes each. Okay, step one. There is a thing called general counting principle 1. It says if there are n1 ways to accomplish task 1 and n2 ways to accomplish task 2, then there are n1 times n2 ways to accomplish both tasks. Pretty clear. If there are n1 ways to accomplish task 1 and n2 ways to accomplish task 2, then there are n1 plus n2 ways to do either task 1 or task 2. Okay, quick example. How many distinct positive divisors does the number 1400 have? Okay, this is like a middle school math D problem. So you've either seen this before and you're like, duh, or you've never seen it before and you have no time. I'm giving you now to think about it. So here's what you do. You do the prime factorization. Do the prime, well, I'm done. Factorization of 1400, and you get like 2, 700, and then like 700, and then like 25, 4, and suddenly I have performed the prime factorization. So it turns out that 1400 is just 2 cubed times 5 squared times 7. Well, now all things are revealed because every divisor of 1400 must be some number of 2's, some number of 5's, and some number of 7's. So if I want to choose a divisor, I have to choose, well, how many 2's? How many choices are there?
4.
4 choices. I can take either no 2's, 1 2, 2 2's, or 3 2's. How many 5's can I take? 3. How many 7's can I take?
2.
Or yeah, 2 choices. Either take none or take 1. Here, take none, 1, or 2. So the answer is there are 24 different distinct positive divisors. Okay, good. Next. How many ways are there to permute the characters from MONTGER? Oh yeah. So we're just putting all the numbers in some kind of order. Well, what character goes first? What? How many ways are there to permute the characters? Oh yeah, so I have 7 characters, right? How many choices do I have for which character to go first?
7.
7, so times 6, times 5, times 4, times 3, times 2, and then that's just it, right? So there are 7 the answer is there are 7 factorial ways to permute the characters from the sequel. And in general, and you might even take this as a definition of n factorial. N factorial is the number of ways of permuting n objects. Okay, how many 4-character strings can be made without repetition from the letters in this set? Well, now I'm only doing 4 of the characters, right? So now I have 7 choices for which to go first, then times 6, then times 5, then times 4, and then I just stop, agreed? And what is this? It's 7 factorial over 3 factorial, and then that's all. Okay, good. So how about if I'm doing this in general? If I have n objects, and I want to arrange k of them in order without repetition, we call this symbol npk. That now?
I misinterpreted in order.
Okay, good. In order. So what do we do? Well, I have n choices for the first one. For the next one, I have n minus 1 choices. The next one, n minus 2. And I go all the way until I'm choosing the k objects, right? So the last one I pick will be n minus k plus 1, I think, right? Yeah. And what is this? This is just n factorial divided by n minus k factorial. Okay, so fact, npk is n factorial divided by n minus k factorial. And I think the easiest way to see this is to do the multiplication. If you arrange, if you pick k objects from n total objects and put them in some kind of order, and then you multiply by n minus k factorial, well, here you've ordered the first k objects, and now you've ordered the rest of the objects as well. And the product of all those orderings is simply the total ways to order all of them. So that's like a proof of that formula. We good? Good, because we have no time left. Turn the camera. Up here. How many 4-character strings can be made with repetition from all of these letters? So now I get to use the letters more times if I want. How many choices do I have for what letter to go first? 7. How many choices do I have for what letter to go next?
7.
Also 7. So this is just a stupid problem. Good, we're done. Next. How many ways are there to choose 4 letters from this set? Well, now I take the 7p4 ways there are to order the 4 letters, and I divide by 4 factorial because I want to divide by the 4 factorial number of ways of scrambling them within themselves. Not if you're with me, if you're not crying. Good, no one's crying. Next. How many ways are there in general now if I have a set of n objects to choose k of them? Well, I claim that this symbol, n choose k, the number of ways of choosing k objects from a set of n objects, is just npk divided by k factorial. And again, my sort of talking it out proof is, if I choose if I choose from n objects, if I choose k of them, and then I multiply by k factorial, then that becomes simply the number of ways of permuting the first k of them. Agree? Okay, good. Here comes the new stuff now. Oh no, this is not new yet. How many strings of length 8 can be made from a set of 20 x's and 10 y's? Wait, is this good? Is this a good problem?
No.
No. How many strings of length 30 can be made from a set of 20 x's and 10 y's? That's a better problem. Much easier now. Yeah. Yeah, this is just 30 choose 10, right? Because I take the 30 spots and I choose which 10 of them will have y's in them, and then the other ones just have x's in them. Good? Okay, now here's the new thing, which if you haven't done math your whole life, you've never done this before. If we have an unlimited supplies of letters from the set MONTGER, and I want to I want to make strings of length 8 from that. No. How many ways are there? No, let's do 20. How many ways can we choose 20? Ways to choose 20. So I have an unlimited number of M's, an unlimited number of O's, a limited number of NTGERs, and I want to choose 20 letters. If you've never done this before, then it's hard. So wait, hold on, wait a second. So here's what you do. You think of yourself as having $20, and you let this be the general area for the M's, this be the general area for the O's, this is stars and bars. 4, 5, 6, 7. So you go 1, 2, 3, 4, 5, 6. And you say, okay, this is the M territory, the O territory, the N territory, the T territory, the G, the E, and the R. And then you have $20, which you may just like distribute throughout the region. And every one of those dollars says how many of those you're going to get. And there are many, many ways to distribute your $20 through these 7 regions. And every one of them results in a distinct string of length 26. And so there are 26 choose 20 ways to do that. All right, if you didn't understand that, sorry. Google stars and bars, or I'll explain it better next class. Bye. That was